Hello everyone, I cordially welcome you all to another video from the React tutorial series, and in this video we are going to discuss on use callback hook in React. So without any delay, let's get started. So what is a use callback hook in React? The use callback hook is very helpful while optimizing React applications for performance boost. The hook is very helpful when we want to skip running of expensive functions during re-rendering the component. We have a list of dependencies provided to the use callback hook, which when changed only triggers the function. As mentioned, this avoids rerunning of time-consuming functions again and again with every render, thus increases the performance of application. This hook returns a memoized callback function. If you are not sure what memoization is, here it is. Memoization is basically an optimization technique which boosts execution of programs by caching the results of heavy time-consuming functions and returning the cached result when similar input is encountered. That is, similar argument is passed. This highly enriches the experience and improves the application performance when we have to pass functions from parent to child component that depends on reference equality to prevent unnecessary renders. Okay? So why should we use callback hook for optimizing our React application? It helps a component to prevent re-rendering until its props have changed. When you pass a function or method as a prop to a child component, even if you use memo to prevent unwanted rendering of child component by checking props, you will notice the component still re-renders. This is so because of reference equality. Whenever the parent component is re-rendering, it is recreating a new function, thus the props have changed as the new function, though logically same, but is not the same function from the same memory space. This can be avoided by wrapping up the function to be passed as props using the use callback hook. So now let me dilute this information for you. In the previous video, we have learned about React Memo, and what I have said, when you wrap any component using memo, what you basically do is you check the props that is received in the child component. If the props are same, the child component doesn't re-render, and if they are different, the child component basically renders again. Now let me give you a small catch. Not only you are passing data this time, let's say you are also passing a method from the parent component to the child component, and you are wrapping up the child component using memo. Now what will happen if you put a console message in your child component? You will see even if the data which are being passed to the prop is not changed and the child component is wrapped using memo, still the child component is re-rendering whenever the parent component gets re-rendered. This is an optimization issue, correct? So how can we fix it? So remember, whenever you pass any method from a parent component to the child component, always wrap that function or method using a use callback hook and provide a dependency that whenever those dependencies change, then only your function will get recreated. Okay. Now enough of theory for now. Let's go to VS Code and understand by an example. Welcome to VS Code. Here we are going to now discuss how this use callback hook basically helps to optimize the React application. So if you have watched our previous videos, you know we are all putting our hooks within one hooks directory, and within this use callback hook.tsx file we have created our to-dos component. Let's see what this component does. It accepts props, to-dos, basically the list of tasks, and secondly a method add to-do from the parent component. Okay. So how we have achieved it? Firstly, we have created an interface iToDos. It has a property id which is of type number and another property type task which is of type string. Thereafter, we have created an interface iProps which contains to-dos as a property, and this will be an array of iToDos. And thereafter, we have an addToDo method which it receives from the parent component. So this addToDo is a property of this iProps, and it will be of an React.mouse event handler. So this will be an event handler function which will be triggered from an HTML button element. Okay. Thereafter, within our to-dos child component, we receive the props which are of type iProps. Thereafter, we have put up a console message that child is rendering to count how many times our child component is getting re-rendered. Okay. Thereafter, we have destructured the to-dos array and the add-to-do method from the props that we receive. Within our return, we have our JSX code which gets rendered on the UI. Here within h1 tag, I have written my to-dos, and thereafter, as we have learned in one of our previous videos regarding list rendering, that we are rendering a list of items on the UI by passing the task part of this to-do as a string which is to be displayed, and the to-do.id, that this id which it receives, as the key. Because as I have always told you, whenever you render a list in React, always use this key attribute for optimization. Okay. Finally, we have a button element on clicking which it calls the add to do method which it receives as the props from the parent component. And finally, we have exported our child component and wrapped it up in a memo just to optimize it. In case if the props change, it should re-render, otherwise not. Finally, within our app.tsx, we have done two things. One, we have created a counter. Basically, you can see const count set count equal to useState 0. So the initial value of the count is 0, and we get another method set count to update this count variable, and these both are provided by the useState hook as we have already discussed. Thereafter, within our return, we show the current count, and we have two buttons to increment or decrement the counter by 1. So if you have watched our previous video on the useState hook, this concept should be absolutely clear with you. And if you haven't watched it, I will request you to please go and watch that video first. Otherwise, this will be a bit hard for you to understand. Thereafter, we have set up another local variable tasks and set task, which will be returned by this useState hook, and by default, the tasks variable will contain this dummy data which I have prepared here, which contains an ID and a task property. So ID are basically of type number and task is basically of type string. Finally, we have our add task method. What it does, when it gets triggered, it returns a new array. It sets up the previous task as it is and adds the new task. And what is the new task? It will be get a good sleep. Okay. Finally, we call our to-dos component from within our parent component. We pass the to-dos which it should by our local tasks variable which is set up by this useState, and add to-do which the child component wants as its props by this add task method. Okay. So basically this add task and this task are passed to this to-dos component as props. Okay. Now what should happen? You might suggest that as we have wrapped our child component using memo, so in this case, even if we are updating the count variable by +1, -1, anything, this to-dos component should not re-render, because neither we are updating this task local state variable, nor we are updating or changing or manipulating this add task method. So let's run our application and check if it is working. So I will go to the terminal and write npm start to run our React application. Let's wait for some time until our application loads. So our application has started. When I go to the console, let me clear everything up for you. Now as I have wrapped our child component, that is this part, my to-dos. So if I increment or decrement the local state variable of the parent component, the child component should not re-render, right? Let's see what happens. See what happens. Whenever we are incrementing or decrementing the value, the child component is also re-rendering. But this shouldn't have happened, correct? Because we have wrapped our my to-dos using the React memo. But why is it happening? So let me tell you why. What happens in this case, whenever you are updating the value of this count variable, basically your parent component is getting re-rendered. And as soon as it gets re-rendered, this add task function is actually created afresh in the memory. So now you might think we are passing the same function to our child component, but internally it is not so. Every time your parent component re-renders, it basically creates a new function add task and passes it. So the new function and the old function are not basically pointing to the same memory space. So to your child component, this function prop is basically changing. But this shouldn't have happened. So how we can avoid this condition? So we will wrap this addTask method within a useCallback hook. So what it will do, until and unless this task's value changes, it will not recreate another function in memory. Okay. Now let's see. See, I am clicking on increment and decrement now, but the child component is not re-rendering because we are passing the same props now. The referential integrity problem which was previously there due to recreation of that function is now gone. Now, if I click add to do, you will see then our child component re-renders. If we click on increment or decrement, nothing happens. Okay. So I hope now you have understand that how wrapping up functions within a useCallback hook and passing it to child component helps in optimizing the React application. So this is a pro tip which you always must remember. Whenever you pass any function as prop to a child component, always wrap it up by a useCallback hook so that whenever your parent component will re-render, your child component will not re-render if not required. Okay. Let's go back to our slide. I hope you found this video informative. In case you like it, feel free to hit the like button and subscribe to our channel. We are going to bring more videos in the future. For any queries, doubts, suggestions or feedbacks, feel free to post them in the comment section. We are going to reply. So thank you for now. See you in the next video. Bye.